Welcome to the 7th of the Rescale Solutions Live webinar series featuring hands-on demonstrations of the top science and engineering applications on Rescale. My name is Jolie Hales. I'm with Rescale and I will be your moderator today. And today's focus is on how to streamline MSC Nastran workflows on Rescale. We'd also want to make you aware that the next webinar in this series will take place a week from today on August 12th. They happen about every week or two, and that one will show how to manage HPC across your organization efficiently using Rescale. We have a lot of cool new features that make it really easy to manage your workflows, and so that might be worth it to check that out for you. And then we also have a special webinar on August 19th, where we will be discussing how semiconductor companies like Samsung are pioneering EDA in the cloud. So some exciting stuff there as well. You can find webinar registration information for these and other upcoming webinars on rescale.com, or you can take a look at any of our social channels for that information as well. And you can also find many of our past webinars that are uploaded to the Rescale YouTube channel. So feel free to take a look there if you want to learn more about a Rescale feature. So we have two presenters lined up for today. A little bit of information about them. The first is our guest presenter, Bhumi Gadia, who is a product marketing manager at MSC Software for MSC Nastran, Mark, and Patron. Prior to taking up this role, she worked at MSC Software for 6 years in the technical support team, where she helped customers use these products, as well as MSC Apex. So she is not just in marketing, she knows her stuff in the product as well, which is pretty unique and cool. Bhumi Gadia holds a Bachelor's of Technology in Mechatronics Engineering. I probably said that totally wrong. Obviously, I do not have this degree, from India, and her Master of Science in Mechanical Engineering from Cal State University, Long Beach. And then after Bhumi, we'll hear from Eric Muir. And Eric is a solutions architect at Rescale, and he has a decade of both academia and industry experience in structural dynamics, aerodynamics, and aeroelasticity, and has recently focused on machine learning applications in computer-aided engineering and autonomous vehicles development. He is enthusiastic about Rescale's vision to enable engineering and scientific simulation in the cloud and help accelerate the next generation of technological breakthroughs. I love that. Prior to joining Rescale, Eric Muir earned his bachelor's, master's, and his PhD in aerospace engineering from the University of Michigan and worked at the Boeing Company in Seattle, Washington. I have a feeling that a lot of our attendees have similar impressive resumes. So at this time, I will go ahead and turn webinar control over to Bhumi from MSC Software. So Bhumi, give me a second and I will let you head on over.
Okay, great. Thank you, Jolie, for the introduction. And hello, everybody. Thank you for attending today's webinar. As Jolie said, I'm Bhumi Gadia, the Structured Product Marketing Manager with MSC Software. And today we're going to talk about MSC Nastran on Rescale, as Rescale is our tight integration partner for cloud services. So here is the agenda for today's presentation. I'll first go through the quick tour of MSC Software as part of Hexagon MI. Then we'll go through some of the cloud terminology, which many of you might be already familiarized with, but we'll go through it just in case if anybody's new to cloud computing. And then we'll go through some of the MSC tools offering on Rescale. So we are offering not just MSC Nastran, but some of the other tools. So I'll give a brief overview about those. And then we'll next go through, since we're talking about cloud computing and stuff like that, it's very important to highlight the fine tuning that you can do with MSC Nastran for analyzing your large models. So we'll give you some tips about the memory fine tuning, HPC Best Practices, and improved GPU acceleration in some of the recent versions of MSC Nastran. And then I will pass on the presentation over to Eric, who will show you the setup of the analysis on the Rescale platform and give you all the live demonstration of, I'll break the news to Eric here, fan laid out model, which is going to be really interesting with Solution 400. So let's get started. I'll go through the brief overview. So MSC Software was acquired by Hexagon AB in April 2017. MSC has over 50 years of history dating back to the moon landings by NASA. And we pioneered the CAE software in the, by MSC Nastran. Basically, there was a contract awarded to MSC software back in, back 50 years ago, and we are the top 10 original software companies. So we're a very trusted predictive design and engineering technology provider with strong history in automotive and aerospace industry segments, amongst many other segments as well. So I would like to give you a brief overview of the MSC portfolio itself. Many of you might be already having the MSC One portfolio, which includes all of these softwares, the structured software, Nastran, Apex, CAE Fatigue, nonlinear structural software, Mars, explicit transient dynamic multiphysics software, Dytran, Simifact, additive forming manufacturing software, Digimat for materials modeling, acoustics and noise software, Actron, fluid and thermal analysis software, Cradle, and then also the autonomous vehicle software, Virtual Test Drive, and last but not the least, multi-body dynamics and motion software, Atoms. So the reason I'm highlighting MSC One is because the Rescale platform is able to access the MSC One tokens. So if you're already an MSC customer, you can use your MSC One licenses on Rescale. So we'll go through those in detail a little bit more. So first, let's take a step back and go through some of the cloud terminology. Most of you might already know the cloud servers are located in data centers all over the world, and then the companies access them through the internet. So there are two types of clouds, private cloud and public cloud. The private cloud is a server, a data center, or distributed network, completely dedicated to one organization, and the customer must have the cloud subscription with the cloud provider to have that. Whereas the public cloud is where the service is run by an external vendor that may include servers in one or multiple data centers. So the public clouds are generally shared by multiple organizations. So people with, ITAR compliances and so on, they generally prefer to have private cloud. So Eric will talk a little bit more about it in his presentation as well. Let's talk about a little bit more in here, infrastructure as a service, platform as a service, and a software as a service. So these are the terms that I'll refer to and Eric will refer to during his presentation. So for infrastructure as services, you can see some of the platforms such as Google Cloud Platform, AWS, Microsoft Azure, and so on. Platform as a service, we tightly integrate with Rescale as our partner, but there are several other solutions as well that we partner with, but our closest partnership is with Rescale. And software as a service, we do provide Mark, Nastran, Digimat, Atoms, Cradle, and Actron. So these are the softwares currently provided from Rescale platform itself. So let's go through some of the terminologies here. So this is very typical. There are two types of model. One is bring your own license model, where you have your license server that is set up by your organization, and then the employees can be working from anywhere at their leisure, like from home, in some cases from the beach or while camping. And then the customer's cloud subscription is, using Rescale and then calling out those licenses from your license server, and your employees can run those licenses, like the analysis of MSC Nastran or other softwares, and then or they could use a public cloud. So this case is the private cloud, where it's your organizational cloud, whereas the public cloud is used by multiple organizations as well. Rescale installs and tests MSC software, and we tightly work with them and provide them our feedback continuously. So that is something that we do. Next, we have pay-as-you-go license format. So in this one, you basically, Rescale have installed the software on their site itself, and you pay as you use. And only Software Cradle is available on demand today. So it's similar to Bring Your Own License, but just, all other softwares are available in Bring Their Own License, but just Software Cradle is as pay-as-you-go. So as I mentioned earlier, here's how the Rescale interface looks. Eric will show a live demo later on as well. But basically, Actron, Atoms, Software Cradle software, Digimat, Dytron, EZ5, Mark, MSC Nastran, and Cinefactor Welding are available today. All of the other softwares except Software Cradle are bring as your own license, so you can point to your existing license server or your MSC One token system as well. So the platform, is the workflow is very simple here. You basically choose your software, and you choose either you want to use Nastran, Mark, Digimat, Adams, Cradle, or Actron, and then you can also choose your version when you choose your software platform, and then you can go to choose your license, bring your license or Cradle on demand, and then choose your compute, select your CPUs, GPUs, memory allocation, and stuff like that. Deploy your compute and access the results as well. So one good thing about Rescale is that your results files get really large. You don't need to download them to your computer. You can just directly point them to your post-processor machine, and that results are accessed directly from Rescale. So that's one advantage as well, which saves file transfer time as well. So we're running the distributed teams campaign where Rescale is offering 50 MSC customers, and special offer where we are. So there is a ScaleX. So ScaleX is your private cloud solution from Rescale, and the typical value for that is around $10,000 to $20,000 that they charge to the OEMs. So ScaleX Enterprise seats per new account will be provided as well from Rescale for 50 MSC customer accounts. So the first 50 MSC accounts will get up to $10,000 of complimentary cloud services per account via Rescale. And Rescale will offer Amber and Carbon core types as well. So they're limited to 1,000 concurrent cores per account, and total simulation time offered is about 200 to 2,000 hours, depending on the usage. So this is a special offer, and Eric will talk more about the Rescale ScaleX. So I'm going to skip through this slide real quick, and here is how you can apply for this special offer. So you can use your cell phone, open your camera, and that will bring you to the website directly. So just scan the barcode using your camera, basically. So let's move on. So since we're talking about large models and everything, it's very tempting for me to talk about the high performance computing using MSC Nastran. So we'll go through some special tips and tricks for those first before I pass it on to Eric. We'll first go to memory fine tuning, where we will give you how the memory usage in MSC Nastran works. Memory reduction for high frequency ACMS with structural damping, K4 matrix, and then automatic DMP memory allocation as well. I'll talk a little bit about that. Next, we'll move on to HPC Best Practices, where best memory settings to run your job. Automatic solver selection capability from MSC Nastran using solve equals to auto, some of the parallel settings, as well as performance and efficiency improvements for MSC Nastran avionics site interface. Cassie iterative solver support for inertia relief, param inrel equals -1 for linear static solution 101, and then also the improved GPU acceleration support. So we'll talk more about that as well. So I'll try to be as detailed as possible here, but in the interest of time, this is just more mainly focused on Rescale, so we'll be as fast as possible as well. So memory usage with MSC Nastran. So default memory and depot allocation using memory close to max is, so this has been given by MSC Nastran. So default memory max values is 50% of physical memory. Default memory equals to max behavior is generally for static solution 101 and 400 is a use estimate program to determine open core memory, high core needed for solver to avoid spill, and allocate remainder to the buffer pool. For all other solution sequences, we set the B pool automatically to 25% of the memory, and high core is approximately 70% of the memory. So these are the settings given automatically from Nastran. So all you have to specify is memory close to max when you are running your job. So here's how it works for solution 101 and 400. As I said earlier, memory equals to max allocates 50% of physical memory, whereas for all other solution types, the 50 RAM is used. So this is how it looks like. The default memory people allocation is 50% of the RAM. So the only question you really sometimes we get from the customers is that was memory equal to max enough? So in order for you to check that would be from the FO4 file, find the disk usage near the end, high water and total IO. Usually the large values indicate the performance bottlenecks. Generally those don't happen, but if in case you're getting large values, then that is the performance bottleneck there. Increased memory max increases the memory and people allocation and reduces the IO, basically. So this is some of the recent enhancements done with MSC Nastran. So memory reduction for high frequency ACMS with structural damping K4. When we do the NVH for electric vehicles, they require high frequency fiber acoustics up to a frequency range of 3000 Hertz. And such high frequency levels, there may be 50,000 to 60,000 eigenvalues for typical automotive vehicle applications. This has caused issues with high memory usage computation for reduced K4 structural damping matrix. And that's why we have added this capability of memory reduction. So the benefit of this is it reduces about 90% of memory requirements in some cases, and it makes the performance 25% faster due to the efficient computation of K4 matrices. So the usage of this, there is no user action necessary. It is automatically done within MSC Nastran, and it's just improved computation, which is handled internally. So as you can see here, the latest version, the second latest version, I should say. By the way, let me take a step back. The latest version of MSC Nastran 2020 is released May of 2020. So this was just added in 2019 FE1, but it does carry forward to the newer versions as well. So that applies to 2020 as well. It may be even faster in some cases, but at least this is available for sure. So as you can see here, the memory allocation was way less in this case because of this enhancement. So let's move on. Automatic DMP memory allocation. Again, as these high frequencies for electric cars, they reach the high frequency levels, the memory allocated for slave DMP processes by default is very low. So the default value for DMP mem is 80. This means that by default, the master DMP processes will allocate 80% of memory specified for memory max keyword. So the benefits of this is better memory allocation for both master and slave DMP processes, and 90% improvement in IO for slave processes, and 90% improvement for high water disk for slave processes as well. And again, this is automatically allocated by MSC Nastran, so no user input is required. And with this announcement, MSC Nastran now allocates the DMP mem automatically based on the model characteristics in order to make sure that there's no fail when executive frequency response calculations are done. So it goes through your Nastran cards and your before you run the job, basically. So here is the comparison. For the master and slave, the memory allocation is way less here. The high water disk is 4 MB, whereas for slave, whereas in 2019 version was 7 GB and 84 GB for the master, whereas 66 GB for the master in 2019 FE1 and 2020 version. So HPC Best Practices. Again, this site is automotive focused, but we'll talk about the generic industry focus as well. Here we have for automotive industries, generally they run the Solution 103, 111, and Solution 108. The optimal memory and parallel settings are done as well, and the solver selection, automatic solver selection. This applies to all the industries, not just automotive. I should highlight that. And then the references. So if you want to learn more about the HPC with MSC Nastran, you can refer to the MSC Nastran High Performance Computing Users Guide, also the Nastran Dynamic Analysis Users Guide as well. So the goal for doing all these things from the Nastran development team is basically to minimize the user responsibility for optimal performance, and instead of that, just automating everything, and especially the resource allocation and the solver selection. So you don't have to worry about the nitty-gritty of the analysis itself. So the HPC best practices, as I said earlier, Nastran has the command memory equals to max, and that automatically allocates the memory. Total memory allocation is specified by memory max equals to val. The users can, of course, do some manual settings and input the memory value, memory equals to value, and default equals to value as well. Memory equals to max also handles the memory allocation for DMP processes. As I said earlier, DMP memory allocation is controlled by DMP mem command, and that is DMP mem equals to value, and default is 80%, so that 80% of memory max is allocated to master, and remainder is divided by the slave. So we'll just go through this real quick. Again, this one is more focused for automotive, but SMP for solution 103, SMP only is recommended. Exception is large number of eigenvalues, approximately over 10,000 number of eigenvalues. Use DMP SMP combination. For solution 111, DMP SMP combination is recommended. Use DMP equal to 4 and set SMP equal to n, where n is n core divided by DMP. DMP is critical for solution 111 with frequency dependence, where fast FR is not possible. Consider increasing the value of DMP and also using multiple hosts. So this is something that the automotive customer I know might be taking screenshots of. So this is the best advice given by our HPC expert at MSC. So next, moving on to the solve equals to auto and CPU max equals to n. So this applies to all the industries. Use solve equals to auto to select the optimal memory, parallel, and solver settings automatically from MSC Nastran, and it determines the model characteristics that go to your Nastran input file, looks at the solution, size, model composition, etc. And then it determines the best solver for it, ACMS, Paradiso, Cassie, etc. It estimates the memory requirements as well. It selects the solver and then sets the memory and depot value automatically. And then it selects how to partition available cores, GMP, SMP, up to CPU max value. And then the limit number of total core is done by setting CPU max equals to n. So this is something that is very good for all the Nastran users. If you're running large models, this could be very, very useful. So going more into detail for solve equals to auto, machine learning can predict the memory required for Paradiso solver. For solution 101, users who choose to disable the Cassie iterative solver can specify Cassie equals to no with solve equals to auto. In this case, machine learning capabilities can predict the memory requirements to use the Paradiso for solid dominated models. So this option allows Paradiso or MSC LVL solver to be used. The Cassie iterative solver is usually faster for solid models, so this is something to keep in mind. Automatic solver has been enhanced significantly to improve the performance of small solution 108 models with lots of frequencies. So Nastran can predict the required memory for Paradiso solver in solution 108, and it selects the best DMP settings based on minimum between n cores and frequencies and ratio of memory available divided by memory estimate, and the remaining cores are given to SMP. So solve equals to auto can be defined by individual runtime configuration RC5. So in your installation time itself as well, you can specify this. So here are some comparisons for solve equals to auto. So solution 108 model with 500K nodes and 9 frequencies. So set DMP equals to 9, and since the system had 20 cores, each DMP process allocated 2 cores for SMP, and we were able to achieve 2 times speed up. So I should mention, solve equals to auto enhancements have been done since version 2018.2, and ever since we have made it even better. So this is just showing version 2018.2 onwards. So all the other versions have 2x speed up since 2018.2 version. And then here is another model where we did solution 108 model with 3 frequencies. Solid goes to auto in 2018 did not use DMP due to insufficient memories, whereas with this one, it did not use the DMP due to insufficient memory, but gave remaining cores to the SMP. And that brought the speed up to 4 times speed up with solid equals to auto. So these are some of the benchmarks. Now, adding on to that, I will add that performance and efficiency improvements for Nastran AVL Excite interface was also done. So I'll just skip through this really fast. So if anybody's interested to learn more, please reach out to me. I can talk more about it with you. But basically, MSC Nastran and AVL Excite interface was streamlined in 2019, and additional performance improvements were done in 2020 version as well. So the case control input AVL EXP command is needed, and EXP SE out may or may not be specified. Domain solver ACMS is to be specified to use the ACMS to reduce the model to an ASET boundary condition. So moving on here, you can see that there was a significant reduction in the performance. Improvement in the performance. So you can see that the max disk space required was way less, and the disk I/O was way less as well, and the time was significantly lower as well to run this job. Moving on, Cassie Treasure Solver support for inertial relief, parameter -1 for solution 101. So Cassie Solver is efficient and robust treasure solver that uses element geometry to form an effective preconditioner. So the interface, this interface is to this solver was never attempted for initial release analysis before. So we have added that, and large solid models would benefit from the availability of Cassie Solver. So faster job turnaround, reduced resource requirements like memory, I/O, disk space, etc. And the target is large automotive engine blocks as well as static analysis jobs done. So it is supported with parameter, and then parameter -1 will be supported in future versions. Just to be noted here. And then again, this is some performance comparison. As you can see, the time was reduced significantly from 6 hours to 30 minutes, and the disk space was also significantly reduced here. Moving on to GPU acceleration improvements. So we have been continuously working with NVIDIA for that. They are our technology partner as well. So for NVA simulations, you can see here that we rely heavily on the matrix multiply add calls for FastFR, which is fast frequency response analysis that we have added in MSC Nastran. So you can see here that with the GPU usage, there were significant performance enhancements done for different models and different scenarios here. There was up to 15x improvement in some cases, and then also the time lapse was 1.6x less time, and so on. So 2 times improvement in some cases as well, and so on. So there is the next slide. Here is the detailed information about the model itself, as well as the model capability as well as the GPU specified. So you will notice here that we have used NVIDIA K40, but there are some newer versions of NVIDIA GPUs as well, which you can use, and you can get even better performance improvement as well. So here is our quote from one of our customers, Volvo Car Corporation. They were able to get up to 50 times faster run due to this GPU usage with MSC Nastran. So again, adding on to that, we have added some more capabilities to version 2020. So in previous version, there was version 111 with FastFR and MPY-add, but and then in version 2020, we are also supporting other solution sequences for multiply add. So for all other customers that are not using just solution 111, but all other solution sequences, you can get a significant performance improvement as well with multiply add functions within MSC Nastran. So you can take advantage of GPU without the upper limit on the model size, and no GPU minimum memory requirement is there's no bottleneck for that. And then older as well as newer GPU architects can be benefited. So only NVIDIA CUDA compatible GPUs are supported in version 2020. So just keep in mind about that. The usage, again, there's no additional change to command line inputs required for this, and you can request GPUs with GPU ID equal to 0 or 1, or 0 to 1, for example, and then you can get speed up to 2 to 3 times on overall elapsed time. And then for solution 111, we're able to reduce times up to 42% in this one, as in this case scenario here. And it's executed on one Kepler K40 NVIDIA GPU, which was launched in 2013. So this was the reason we did the test on this one is because some of our a lot of our customers do use the older GPUs. They haven't moved to the newer GPUs because they're obviously quite expensive. But with that said, the benchmark was done with that, but we do support the latest GPUs as well, and that you would get even better performance improvements with newer GPUs. So that's it from my side. As I said earlier, there's a special offer from Rescale, so please scan using your cell phone to apply now. And if you have any questions, please do email me at this email specified. And with this, I will pass on the presentation to Eric, and he will go through the live demonstration.
All right. Thank you so much, Bhumi. I appreciate that, Eric. I'm just turning over control to you. We will bring this QR code, if you don't mind, Bhumi, we'll bring this up at the very end of the presentation as well. So if you didn't get a chance to grab it, you can catch it during the Q&A. I see you, Eric. Do you have control over showing your screen?
Thank you, Jody and Bhumi, for the nice introduction there. So today I'll be going through a little bit of an introduction to the Rescale platform and sharing that with you, and then I'll go into a live demonstration and show how you can really leverage the Rescale platform in combination with MSC Nastran to improve the overall experience, efficiency, and workflow of doing multiple loads analysis, where normally that would require a large number of custom-built scripts and things of that nature. And I don't know why my dock is frozen here. There we go. So just wanted to emphasize again, building off of Bhumi's points earlier, that there is a growing market trend in the HPC world of moving the entire ecosystem of the HPC to the cloud. And when you look at this, there's a lot of benefits that moving an HPC system and an engineer's use of those resources to the cloud can provide. So first of all, you gain a large benefit in terms of shifting capital expenses to operating expenses, allows you to optimize how you're using those resources and the cost associated with them. It also allows you to trend towards more on-demand access to both hardware and software, so that the engineers in your organization have the tools and the resources when they need them and at the scale that they need them at. And then finally, as we all know, HPC resources, both from a software as well as from a hardware standpoint, are continually being upgraded, and new core types, new GPU processors, new softwares are constantly being made available. And by leveraging the large backbone of the cloud infrastructure, combined with, working together with the software providers like Hexagon with MSC software, you're really able to have the latest and greatest HPC resources at your fingertips. And so with that, I bring the conversation to the Rescale platform. Rescale is a cloud-based HPC experience that's comprehensive of the entire HPC ecosystem, and it's culminated in a very easy-to-use web-based portal so that engineers can leverage the cloud resources provided by the various cloud providers indicated below, such as AWS, Azure, and Google Cloud, combined with a whole host of over 450 different HPC software to be able to improve their efficiency, make better and faster engineering analyses, and ultimately design better engineering products. And so Rescale pulls all these important components together into an easy-use platform where we've taken the entire HPC stack, which includes not just the software and hardware, but the entire middleware as well. And we've combined that and managed all of that into an easy-to-use system for the engineers. We also provide a lot of administrative and security features and tools to allow organizations to effectively manage and enable their engineering teams to get their jobs done on time and on budget. So just digging in a little bit further, when I talk about HPC system and the entire stack being part of what Rescale offers, if you break it down, there's over 12 different elements that a typical on-premise HPC system has to include in order to have an effective HPC system. And so Rescale combines all of these, manages these for you, all the way from the optimizing the software installation down to offering the various hardware types. And so that at the end of the day, engineers and organizations can leverage this platform to ultimately get to the engineering analyses that they need. Rescale is based on a global cloud platform, which has leverages cloud data centers across the world. And so we are able to provide several different production environments for you to run your analyses and leverage those global cloud resources. But we are also able to do so in and provide platforms such as a US-based ITAR cloud platform. So to ensure that all the data policies and security policies needed for your various analyses are able to be maintained. And lastly, a point that I like to drive home, particularly as an engineer and as a user of HPC for many years, what Rescale provides when you pull together all of these different components is a platform that empowers engineers to really improve their productivity. And so when I talk about that, I like to emphasize that, Rescale, in addition to providing a web-based UI, which I'll show you today, it also provides a lot of other features for interacting with, automating your workflows, post-processing scripts, so that you can get your analysis done from pre all the way to post-processing faster. You can gain insights from that analysis quicker, and you can iterate and ultimately produce products to market faster. So Rescale has an easy-to-use web UI. We also feature a command line interface and REST API for automating workflows and interacting with the Rescale HPC platform without going through the web browser. I particularly like the Rescale API that you can use with Python so that you can use modern software tools to automate your workflows. As I mentioned, Rescale has over 450 different softwares. And I just like to point out that, in addition to engineering tools such as MSC Nastran, you also have available to you a whole host of open source and other tools that engineers are typically using in their tool belts for things like pre and post processing. So Python, having access to all the features there, Singularity containers, if you're doing any kind of CUDA enabled work, all of these tools are also made available alongside the hardware and software on Rescale for your use. And then finally, when we talk about a vast availability of hardware, we really do have the latest and greatest options in terms of CPUs, GPUs, core memory, and interconnect technologies so that you can optimize the software that you're running with the hardware that you're running it on. So today I'd like to showcase a loads analysis with MSC Nastran using the Rescale platform. And for this demonstration, I chose to present the fan blade out loads analysis that I worked on both in grad school as well as my time at Boeing. And this is a very important analysis in the certification of commercial aircraft. This is an analysis that simulates the event where a fan blade of a jet engine breaks off and is contained by the engine, but the ensuing dynamic forces are very extreme, and being able to simulate that ensures that the engine and the aircraft maintain a high level of safety through the event all the way down to landing. And so, in addition to this being a very complex analysis, one that MSC Nastran has many numerous features to perform an accurate analysis, it also has it's a very complex dynamic event, and there's lots of different features of that event that you need to account for. So one of them, or a couple of them, include differences in the amount of blade loss that's experienced by an event, where the blade itself releases. Does it release at, say, the 12 o'clock position, or in this case, maybe more like the 9 o'clock, and other parameters. And so typically when an engineer is doing this analysis, they're not just going to run one simulation, they're going to run maybe 20, maybe 50, maybe 100, and look for the worst case scenario and design to that. And so I'm going to show you how you can do that very easily with Rescale's platform, and so that you don't have to hobble together 100 different simulations with different input files, slightly different perturbations on these parameters I've mentioned. So just before I jump over the platform, just to kind of quickly walk you through what I'll be sharing with you today. First of all, I'll show you how we set up a very easy single workflow for a fan blade out analysis. I'd like to point out too that you can share these easily with your colleagues. And then if you want to perform a benchmarking to identify what are the best parameters in terms of hardware selections and other things like that, we have a convenient cloning feature that you can use. Finally, I'll show you how you can then create a design of experiments analysis to be able to run those multiple load cases. And finally, show you how we can leverage the virtual desktops of Rescale's platform to visualize those results and ultimately download them if you'd like to for further post-processing. So here I'll quickly jump over to the Rescale platform. Just wanted to first pull up Rescale's website, encourage you to go there. There's a lot of great resources available to you. And I also pointed out that Rescale's platform at its core is a web-based platform. And so as a user, you come in here to the rescale.com and log in, and we have numerous security features available to you in terms of your login credentials, multi-factor authentication, and things of that nature. Okay, so once you get in here, there's a nice landing page that is brought to you, but ultimately you come to the platform to create HPC jobs and then to submit them and interact with them. So I'll take you to the jobs page here. This is a listing of a bunch of different jobs that I have done. These are all fan blade out analyses. I currently have one running here, which is a design of experiments. But first, I'd like to just walk you through how do you set up a job with MSC for this analysis type, and what are some of the features and aspects of the Rescale platform that might be relevant. So when you create a new job, you can name it whatever you want and can change it at a later point. And Rescale guides the user through this very easy to use workflow where you start with input files, select the software that you're going to be using, select the hardware, any post-processing, and then submit the job to the cluster. Again, this job is going to be submitted on a unique cluster built based on these specifications without any kind of queuing that you might conventionally be used to with an HPC system. So for the input files, you can upload them from your cloud, from a cloud location or your local computer. So for this example, I'll just navigate to the relevant files. And in this case, I have a few that you just pull up here. And it's that easy. And of course, like I said, if these are in your cloud storage, you're able to do them here. So all I've uploaded is essentially a Nastran input file, Python post-processing file, and then a data recovery index file that tells my post-processor what information to extract. The next thing that we will do is look for MSC Nastran as a software tile. And so that's the software we're going to run the analysis on. There's several different versions available. We'll go ahead with 2020 for this one. And you'll notice that Rescale automatically populates the command submission inputs for you. And so that's very convenient that you don't have to remember what the different inputs are. So in this particular case, we're going to run shared memory parallel, and all I have to do is just give it the input file name. And then lastly, as Bhumi mentioned, we have several different on-demand license options. License options, one of which is an on-demand, which is what I'll use, but we also have a lot of options to be able to either host your individual software licenses or to connect to your on-premise license servers. And then secondly, I'm going to include a mini Conda Python environment to install just a few dependencies that I need for my post-processing script. So this is where it's very convenient for you to set up these environments without needing any kind of root permissions or anything of that nature. Okay, so once I have that set up, I can go through here and also upload a post-processing script. And so this is just a command that will be run after my job is completed. So you have that in here. And then finally, you go through and decide what hardware do you want to run it on. And we have a whole bunch of different hardware options available, and can be a bit overwhelming, but we have some, some best practices that our engineering teams can help you with. For this particular case, I'm going to use Rescale's Onyx Core, which gives you a Intel Xenon processor with the appropriate memory and the like to run that. And that's it. That's the setup of a job. Now, when you look at all these different hardware types, you might get a little bit overwhelmed, and also it behooves you to to do a quick benchmarking test to see what the best hardware to run is. And so we do have a clone feature here where you can make a copy of this and just iterate on a few different options. And I've done that. I'll share that just very quickly here. Where I looked at 3 different core types and also increased the number of cores to just look at what's the best wall time and job cost options. And so, you can see here that this Diamond processor, which has a 3.4 gigahertz processor, gives me the best wall time. As I scale up, though, in terms of number of cores, that core becomes more expensive than the others. So I actually, for the DOE, decided to run it on a single core of the Diamond because it gets me the fastest wall time, and it's pretty similar in price. I did actually want to add one more comment about the post-processing. MSC Nastran has a very nice HDF5 output, which is a very convenient output format for loading into tools like Python. You literally can just import H5Py and read that in, and then interact with it like it's a Pandas data frame. And so it makes making your own Python scripts very easy, and all of this can be done in Python or in Rescale's cloud. So once you have that set up, as I mentioned before, you get your job set up, you decide what hardware you want to run on. Then the next, the next task is to then go through and fulfill this entire design of experiments analysis, where you're going to run that model over a whole host of different inputs. So there's just a few changes that you need to make to the standard job. So first of all, what you'll do is go through and select a design of experiments job type instead of a basic job type. And what that's going to do is add in just a few additional new features, the parallel settings feature, as well as a template. And what this ultimately lets you do is to specify what are all the different jobs that you want to run, defined by variable parameters, and then allows you to insert the values of those variables into a template input file so that you can run this over several tens or hundreds of inputs without having to manually create those input files yourself. And so for this particular case, I ran it over just a small number of different inputs. Here I'm changing the mass of the lost blade as well as the release angle. In this case, it's called theta. And so those are two variables that are going to be made available to my template. And then the template is simply just an input file, could be the entire input file, or it could be an included input file, where instead of the absolute value that you want to ultimately run with, you instead insert a placeholder for those variables. And so here in this particular file, I have the unbalanced card, which describes the unbalanced load caused by the lost fan blade. And instead of typing in the actual mass value and release angle, I put those in as variables. And then the last thing here is then you have your hardware selections. And here I again choose diamonds, but I have the choice of the number of slots. And a slot is just a concurrent simulation that you're going to be running. So here I ran 2 concurrent simulations at a time and running them on 1 core. When you launch that job, it's going to spawn however many different child runs that you specified. In this case, I did 8. And it's going to handle automatically all the orchestration of each of those runs. And so here you can see my various mass and theta inputs. If I go ahead and click on this run, I'm able to see all the input and output files specific to that run, including any post-processing results from my post-processing script. So here's some plots that I produced that I can easily visualize here in the web browser. I'm also able to print out and store into the web UI here some key results. So here I might want to know what the maximum fan displacement or the maximum loading at the strut to wing connections. And those values come automatically populate here out of those post-processing scripts. We also have a charting feature which lets you look at different parameters such as fan displacement as a function of the run or as a function of mass. And there's just a lot of great opportunities here for you to interact with the job, to look at the job, to identify, hey, run 6 has a peak in, some particular parameter, so that you can go and further, investigate that particular analysis and what have you. Just paying attention to time here, I'll wrap up, but I want to mention 2 final features that are very useful. First of all, let's say you're content with this job run, or maybe you have some questions and you want to share it with a colleague. We have a convenient way to share this, and they'll be able to see not only the output files, but then they'll also be able to see all of the input settings that you set up too. So they can verify it, they can look at the results, and you don't have to spend a long time downloading large files and uploading them. They can access them just as if it was a job they produced themselves. Then we also have the capability to visualize the results. And by doing that, it's going to spin up a remote desktop that you can connect to in your web browser. And here I have another example of that. And let me refresh this. So while that's refreshing, so these desktops here allow you to either pre-process or post-process your results, and also allow you to pull up programs such as MSC Patran to look at the results and do any kind of graphical interaction with your simulations without the need to download those large files. So with that, I think I'll pass it back over to Jolie and take any additional questions. And thank you everyone for joining, and hopefully this discussion today inspired you and really showcased how easy the Rescale platform enables you to do these complicated workflows with very easy interfaces.
Great, thank you so much, Eric. Appreciate the presentation, and I just turned control over to Boomi. So we've got that. We had some requests to get that QR code back up for the deal with Rescale and MSC software for the first 50 people who sign up. So there's that QR code right there. So let's look at our questions. We have a few of them coming in now. First question is from Jonathan. Is there a limit to the number of concurrent runs you can specify in a DOE? I think that one's for you, Eric.
Yeah, great question. So we do have some limitations on the number of concurrent simulations that you're able to run. That limit is 100. And so, you know, that's a pretty large number for a DOE. You're able to, at any one time, be running 100 simulations. And then, depending on the number of cores you specify on a per simulation or per run basis, there's also a pretty high limit there, depending on you know, the type of account and things you have with Rescale, but it's on the order of 500 or 1,000 cores. So those are the two limiting factors.
There's a follow-up question to that. How can you download results from a DOE run since there may be many?
Yeah, sure. So Rescale makes it very convenient with the DOE in that it keeps all of the results kind of contained and associated with that individual job. And so you have several different options. First of all, you can go through and view the results, filter them by, say, file extension or file name, and download files individually. But if you have a large number of files that you're interested in, you know, extracting and don't want to do that manual process, we have the ability to zip up the entire results file and download it. We also can, we have a feature that allows you to filter only a certain number of, or certain selection of the files and zip those up and download. So in the case of the FBO analysis that I ran, maybe you only care about the H5 output files or the FO6 output files, then you can filter based on those extensions and zip and download those.
Great. It looks like we have a question for MSC software. This one's from Aditi. Are there any limitations on the analysis type or size of the models that can be run? Or maybe that one's for Eric, whichever one of you wants to take it.
So I'll let Hemant or Peter Schartz take that question. Hemant is our development lead, and Peter Schartz is our HPC expert at MSC. So I'll let them take that as well.
Yeah, I'll take that. This is Hemant Patel. Yeah, really, there are no sizes, model size limits or analysis types. It really, it's a function of your licenses as well as the amount of compute resources that are available to you, right, in terms of the limitations.
Okay, thanks for jumping in there. Appreciate having a couple people from MSC Software on this call. We are at time, so thank you so much to everyone who joined us. Just a reminder that our next webinar is on August 12th, and you can find registration on our social channels and rescale.com. And so, yeah, that's pretty much the gist of it. Thank you so much for joining us, and stay safe.